All right, let's get started. So, hi everybody. I'm Medya. I actually just got here a couple hours ago. I had a crazy travel story, misfortune that my friend was actually telling me. Instead of your talk, you should talk about that. That's more interesting. I don't think that would be professional just to talk about my travel stories here, but maybe after a couple of drinks later. So my name is Medya. I'm one of the Minikube's maintainers, and today I want to talk about three things: Minikube, Skaffold, and Helm, and how they would work together. So by show of hands, who has used Minikube or knows? Wow, that's pretty much okay. And Skaffold? Okay, not that many. Okay, and Helm? Okay, that's as much as Minikube. Okay, cool. So what is Minikube? The best way to learn Kubernetes, and actually the real Kubernetes cluster on your laptop. Like, I don't think any other tool provides as real Kubernetes experience on your own laptop other than Minikube. These are the current maintainers. Thomas is our lead, and we have more than 400 contributors across the world. Who am I? I was previously a senior SRE, site reliability engineer at Google Hardware, where I actually managed Helm there. And currently I am a senior software engineer at Google Containers Tools, which we work on open source. I'm so lucky that Google pays me to work on open source things. I cannot be happier. So I work on mostly Minikube, a little bit Scaffold. Minikube started 2016. Anybody use Kubernetes 2016? Oh, wow, that's like 20%, 30%. Wow. Okay. And the idea was you want to be able to run Kubernetes on our cluster, on our machine, and Dan Lauren, he started Minikube repo at 2016 at April, and it has been growing since then. Most of the people use, this is based on a survey that we had, last quarter survey, use it for development, and 5% use it for testing, and 30% use it just to learn Kubernetes. These are like stats. Is some Minikube's architecture is pretty. If I want to describe it, there is a bootstrapper that runs inside a virtual machine. It could be VirtualBox, it could be KVM, it could be HyperKit, and we also run. We have a driver called non-driver, which actually runs basically on your computer. That's not our best driver. Because it only works on Linux, and we have plans to improve that because it basically installs Kubernetes on your Linux. But that one is actually used as a testing tool in Jenkins or other things. People use it to install Minikube inside a VM using the non-driver. And Kubernetes, Minikube supports a lot of different container runtimes, and we have more than I think 16 or 20 add-ons, and we support all the Kubernetes version. I used to work for a company called Target, and where we managed our own Kubernetes, and I remember we used Minikube to emulate our current prod environments, because Minikube lets you to install the exact version of Kubernetes that you want. So we wanted to see if we install this app on this exact version, if we upgrade it from this version to this version, what's going to happen. So it was a real world experience of Kubernetes. And I personally used this when I was as a Target, and I was liking it. These are like the basic commands of Minikube: start, status. Interesting ones are like service and tunnel. Service will give you a URL to the service. It could be a node port or load balancer or any other service, Kubernetes service. The tunnel is a new command that we have, and that's actually makes your network inside Minikube accessible from your laptop as a load balancer. These are the list of the add-ons that Minikube supports. Like, for example, add-on manager, dashboards, all the different. We have a very interesting add-on that we didn't create ourselves. Other people added it as GPU, and I've seen very interesting blog posts on this GPU add-on, and there are more add-ons. Like gvisor is actually one of the most popular one on Minikube, because that's one of the very fast and easy way to try gvisor on Minikube to see how if it will actually prevent the security attacks that it claims it does. You can just test it on Minikube and see for yourself. And this is a different representation of the architecture of Minikube. Like this is like different versions that you can support. For example, currently the runtimes, the purple ones, we are planning to support. Like we support Docker, Cryo, Containerd, gvisor, but we don't support Kata yet. But we are working on it. And another thing that we are also working on, as I said earlier, Minikube runs inside a VM unless in the non-driver. Non-driver just runs like basically on your bare metal. We don't really recommend it on your own machine because it will live over. It will open up ports to outside. Not a good experience for as a developer, app developer. But we are working on running Minikube inside a container, which I will talk about that later. Minikube supports all major operating systems out there: Linux, macOS, Windows, FreeBSD. We used to not have good integration tests for Windows. Actually, our integration tests were not running. We had them, but we were not running. This quarter, we made it our first priority to make Windows a first-class citizen of Minikube and make sure our integration tests run for Windows as well as macOS and Linux. Almost all the features of Kubernetes that you can think of can fit in Minikube. One of the privileges of having using kubeadm inside the VM is like we can basically do everything we want inside there, and we can emulate a Kubernetes environment completely, from volumes, load balancers, runtimes, DNS. I don't see CNI plugins here, but we should have added that. CNI plugins, any kind of CNI plugin you want to try, you can try it on Minikube. The principles of Minikube has always been user-friendly, so it was always meant for a beginner who wants to try out Kubernetes, so they don't feel scared, and they should feel very easy to communicate with it. We really care about being inclusive. And when we say being inclusive, we don't really just talk about it, we actually do it. We recently added 5 written language to Minikube translations, and we noticed something. Whenever we had a user outside US in a country that their main language was not English or not common, and they would just create an issue, just say Minikube doesn't work, an empty issue, and we felt bad that we could not even communicate with them. Like they did all the work of going through GitHub, creating a login, and just say Minikube doesn't work, but there was no logs. But we had an issue template that says, hey, here's how you give the logs, here's how you give the information we need so we can help you. So we actually made issue templates for many languages out there that we used to get, and through Google Translate now we can help them. And it's absolutely a beautiful experience to see that people who used to just come and say Minikube doesn't work and no message, nothing, now we can communicate. So Thomas gave our lead, Thomas Stromberg, he gave a great talk. I suggest everybody watch that. It's called Kubernetes for the Next Billion Users. So in the upcoming years, 1 billion users are gonna come to internet, and none of them speak English, but they all want to contribute to this experience of open source that we have had. But how are we gonna communicate with them? We should really care about the countries that have slow internet, no English, but they really want to be part of this. in Minikube, I think we have done a lot of priority to make sure that happens. And cross-platform, we always never discriminated, even though like majority of the Google engineers like use Linux. We did our best. We recently bought Windows machines to make sure our labs have testing on Windows and all the platforms that people use, not just the ones that we like to use. One of the things I like about Minikube before I was a maintainer myself was like you could trust it. If it was giving you a feature, you could trust that it's working. And one of the downsides has been like Minikube was not the fastest option out there, but I could say it's one of the most stable options. This is a graph of our code base. I'm gonna skip that so we can get to more material. What is coming in Minikube? 5 times faster, 5 times less resource usage, single step installation. Right now, if you have to install Minikube, you have to install VirtualBox or KVM or HyperKit. And those things could be frustrating, especially for new users, like go install VirtualBox and install this driver. So it's one on our roadmap to make sure it's a single step installation. And the user should not even know what is VirtualBox or HyperKit or KVM. We should just detect it for them. It's like, based on your machine, the best thing for you is HyperKit, or the best thing for you is KVM. And we are also moving away from rootfs to tempfs, which is going to make the mounting performance in Minikube tens of times faster than current performance, because it's going to be all in the RAM using tempfs, and it's a much better technology. As I mentioned, we have localization for 5 written languages, but we absolutely love anybody who wants to contribute any language, especially now that we are in Europe. You guys speak more languages than people in America. We would absolutely love your help in adding more languages to Minikube, making it more inclusive. Another critic that Minikube always had was you could stop it, but you could not suspend it. Like, I mean, a VM could be suspended, so you could come back fast. So that's also coming. And remember I said that we have a driver called none that basically installs Minikube on your machine. And that's a terrible experience right now because you have to be a root, and then that it opens up your computer to ports. So we don't recommend it. You're going to make that better. Non-root and no open port to the outside. We are planning on automated bug reports. So even if Minikube crashes, we should provide a way that if you are willing to enable that feature, automatically report it to us. So we don't even have to go through creating an issue and waiting for us to respond to that. I strongly suggest this talk. This is a really beautiful talk, bringing Kubernetes to the next billion users. You can easily find it on YouTube. I enjoyed that talk myself. Okay, so in this summit, I'm announcing something, a preview version of Kick, Kubernetes in containers. And what it is, you can run Kubernetes in containers. And the repo is subject to change. I'm just putting in my personal repo for now. I am super excited for that. And so this is a chat screenshot I got from one of the maintainers. I'm almost booking a vacation to only work on Kick this week. Ha 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 ha. So I mean, I got myself excited on this, and I got other people excited. And then I got more excited that they were excited, and now we are all excited. And it's like an explosion of excitement. And what is Kick? Kick is a library that you could use to start a Kubernetes cluster inside a container. There are other tools out there, but this is a library. This is not a tool. And the difference of Kick as a library is super minimal. And it supports different OCIs. It could be either Docker or Podman. That's why it's called Kubernetes in container. And it's hyper-focused only on handling that part. And it has already features that others don't, like supporting CPU and memory size for the container, limiting the security whitelist. So right now, if people want to run Kubernetes inside a container, they basically have to give a carte blanche for all the security, ignore to Docker, super open, scary security risk. That we don't do that. We only whitelist the one that we actually use. And super small code base and supporting different CNIs. Currently, we are hoping to release this by the next Minikube release. So that would make Minikube 5 times faster and 5 times less resource intensive. That would do a lot of help to the people who develop on Minikube on daily basis. So less CPU usage, start faster, and just get things done inside a container without waiting for a VM to come up or spend your CPU time or your RAM time. As I said, the repo that I said, you could actually go look at the examples there. This is just early, super early preview. I did not intend to make an announcement, but this is because we are here. Let's give you guys a taste of it. This is everything subject to change. Like nothing is gonna be this, even the repo. But this is the taste, and you could see how it works. So the topic of this talk was Minikube, Skaffold, and Helm. Actually, dancing with them. So idea was, so if you want to develop an app for, and you want to use Kubernetes, you first write your code, and then make it, build the image, Docker build, and then push that image somewhere, and then deploy it somewhere, Minikube or a GKE cluster, whatever your Kubernetes is. And then each time you make a change, let's say you change the port of the container, or if you change the mount path, you have to go change all those YAML files, and then you have to verify that it works. It's actually a frustrating experience. A lot of people end up just developing on their machine as opposed to developing inside Minikube or in a container Kubernetes simulation environment. I'm curious here, people who develop, how many people develop on their machines, not on a Kubernetes? Okay, and how many people develop inside a Kubernetes like GKE or Minikube or any kind of Kubernetes? Wow, okay, so more people actually developing on their machines. And that causes some frustrations when you have to translate all of that work from your local machine to YAML files, and every time, is it gonna work? What if you had that same thing, it was just working, you didn't have to change anything, the same thing, just push it to prod. So this is like a small table I made. Local machine has this problem also, like, Python 2, Python 3, right? Like your system Python is Python 2, and then you want to install Python 3, and then screws up everything, even if you use virtual env. Local machine experience, if you develop too many other projects, becomes horrible. And then you have to translate that to a Kubernetes deployment YAML. And then, well, of course, this one doesn't have a build image or deploy image, so you don't even have that. Same story with Docker Compose and Minikube, really. Well, the only advantage of Minikube is this one, is that you don't have to translate the compose file to Kubernetes YAML file. So Scaffold is another tool that my broader team is working on. I'm not one of the maintainers, but I work with them closely. And their focus is to make it easy so you can develop without thinking. Just develop on your machine and just be able to deploy it locally or remotely. How does it work? So you have a repo, and don't even say anything. Just start a repo. Don't even tell it where is anything, okay? Make a Go app or a Node.js or anything. And then just put a scaffold.yaml there. And it automatically tries to understand your repo. It says, oh, this seems like the manifest files. This seems like the app file, the Go app. This looks like a static file. So it watches your source code. and if there is a change in the source code, builds an image for you, and then deploys that to Minikube for you. And then when you change the code as you're typing, it keeps doing that. But also does it much more than that. For example, let's say you're developing an app that's in Node.js and you are mounting a static HTML file to this container. Your JavaScript or Go app code did not change at all, just the static file changed. It will not go rebuild the image, it just syncs the file. So it's much faster, much smarter. I'm going to show you like an example Scaffold YAML file. This you put it in your root. You could actually keep all of these guys empty, but it will try to figure out as much as you want. If we look at this, there is a sync. And this sync tells that anything inside this guy, source *JS, if it changes, do not rebuild the image, just sync the files. So it makes your development much faster. And also, even if I didn't even mention this sync, if we go to this code and look at the Docker file, it will try to infer what things it should sync. For example, in this case, it will try to sync these guys, the copy ones, that the ones that are not your source code or your binary. So in this example, the one that I showed, as soon as you start changing your code, it builds a Docker, syncs the static files, but it won't rebuild the Docker image because it's just HTML static files, and deploys it to Minikube, and then checks that the Minikube service was healthy. And if it doesn't, it will let you know. And by default, it looks for a folder called Kates for your deployment YAMLs. But you can specify any other folder, of course, to where your deployment YAMLs be. Did you have a question? I saw a hand, but I didn't. Okay, that's fine. I think the lights are too much. I saw a hand in the lights. Scaffold. So before we go to the next slide, all I had to do was do scaffold dev, and it will automatically detect my source code. It will try to make a Docker file for it and build it for me. It sounds like magic, but it's not. It's not magic. It's very actually straightforward. Scaffold supports 3 deployers: kubectl, Helm, and Customize. And the rest of this talk, I'll show you an example of how to work Scaffold with Helm. These are the Scaffold important commands that I just separated for you guys. Dev and delete are my favorite because that basically does most what I want. I don't really need it. Oh, okay. It does have a debug, which is beautiful. It doesn't matter if you have a Node.js app or a Go app or C++. No matter what, you can actually debug your code using Scaffold. And for that, you have to watch this talk by David Gejo. I strongly recommend this talk. It's a really good talk. He'll show you how to debug an application. In your IDE, you put breakpoints and you just type. Scaffold builds the app and runs it for you. You can put breakpoints and Scaffold waits for you there. It won't go more. It's very neat. I absolutely love it. Oh, and then why did I name this talk Dance? Well, I started dancing about 1 year and 8 months ago. Let's watch this clip. This is salsa dancing. And if you see, there's a circle of people, and the teacher are in the center. I used to be in that circle, but nobody wanted to dance with me because I was absolutely terrible. It's like, I have to dance with you. It's like, and the teacher is like, hey, come this way, like, I'll work with you, like, separately. It was embarrassing, but I didn't give up. We have some Germans here, right? Can you somebody translate that? It says, no man, I'm not going. I want to dance, right? Is that right? Yeah. So I did not give up. So what I did, I recorded videos and I went home and analyzed them. But analyzing salsa is very difficult. Like you have to, the most important steps are 1 and 7. So 1, 2, 3, 5, 6, 7. 1, 2, 3, 5, 6, 7. 1, 2, 3, 5, 6, 7. So that was like 6 rounds of dance, very quick. So I had to like pause, and it was so frustrating. It's like, okay, I have to automate this process because it took me 20 minutes to like watch one. And but the good news is after 8 months, now I teach salsa dancing. So I went from somebody who everybody's like, go away, so anyway, another thing I was like, I disliked about the players was all the players have the controls at the bottom, like the play and pause. And I wanted to be at the top because the teacher's feet are at the bottom. This covers the feet. You can't see what is happening. Anyway, so when I was preparing, it's like, why not? Like, you know, oh my God, I'm running out of time, I think. Why not use Helm and Minikube? Because I'm a Minikube maintainer. Why not dog food my own food? You know, why don't I, like as I did? And I use Helm, Minikube, and Scaffold to do this. I strongly recommend those talks that I give you guys. Those are like, because this is a short talk, but those will give you so much in more detail. The Thomas and David Gajo's talks. I'm gonna skip quickly till we get to maybe take some questions too. But let's Helm. So I didn't talk about Helm. Sorry. So one beautiful thing about Scaffold is it can actually deploy with Helm. This is the top part is you're familiar with. It just you give it a name of image. You say which folder you should sync so it doesn't rebuild that image. That part we all understand. Anybody who has question on the first part before the deploy? Okay. So after the deploy, we're telling it if it's built and it's deployed successfully to Minikube, also deploy it to where? Deploy it to Helm using Helm. But what? The release name is dgeek stable, and the chart path is in my repository. So I can make a chart and make Scaffold to actually use Helm, which is beautiful because later if I want to deploy the same chart to prod or anywhere else, I am confident that this has actually works on my own machine and it will work somewhere else. I'm not going to translate from KCML to Helm charts and all that mess. I'm just using the same thing everywhere. That's how I do for things. I think I already talked about this. I'm going to skip as much as I can. Oh, how about, so one of the frustrating part of my developing as a developer was like choosing a database. I did not like that. I started with MongoDB and I switched to Postgres and I was like, which one is better? It's like, how about I have both versions and I develop one app, but I deploy them, one with MongoDB, one with Postgres. So you see I have 2 releases in Helm. So I have one dgeek stable and one dgeek canary. This one uses Postgres because I'm replacing the values, the Helm chart values, and I make it use Postgres instead of. So I'm developing one app, but it gets released to two different releases, and I could get to see which one is doing better. And it's all by Scaffold, not me even touching a button. I just say Scaffold dev, and it's just doing all of that in the background. I'm just typing and coding, and just rebuilds and redeploys and lets me be happy. Yeah, and then Scaffold has more features. Like you can actually build pipelines. It says after you deploy to this environment, do this thing. So I'm not going into that. How much time do we have? Let me check. I think we are out of time, but maybe I can do a quick demo. If you want to stay in touch, we have super welcoming contributor experience for Minikube. If you want to start contributing to Kubernetes project, I think Minikube is one of the best places We label the good first issues. If you just search for good first issues, and we actually do guide you through the process of getting your PR done. We absolutely love it when new people come. And if you want to contribute, just keep that in mind. You can ping me on Slack of Kubernetes at Medya, and that's my GitHub. Let's go like a super quick demo, but okay. So right now, a Minikube status. What happened? Okay. Get pods. We don't have anything. Helm list. Okay, so we don't have any pods. No. So I am gonna start this in VS Code. By the way, there's an extension called Cloud Code, which is basically uses Scaffold in the background. That I strongly recommend learning that because it just makes Scaffold like graphical. Anyway, so this is my dance app. I mean, it's just like a template now. Let me make it bigger. So this is the chart for it, the Helm chart for it, right? And you have these values. This is a static folder that I told you guys. So let's go do this. Scaffold dev. Oops, I misspelled it. So Scaffold automatically watches my source code for any kind of changes. As soon as I change something, it smartly understands that was this code or was it like a static file? Do I need to sync the file or do I need to rebuild the image or do I need to rebuild the binary? So let's and then in the another window, let's Minikube service list. So we have it deployed two versions of my app, one the canary and one stable. Let's open the stable. I mean, this is hello. Oops, let me open a new one. Hello Helm Summit. So let's go change this guy to how are you guys? So it changed that. So let's look at the Helm list now. So it has only one revision because it did not make a new release because it was a static file. But if I had changed the code, it was smart enough that says, hey, the Go app was changed. I need to deploy a new binary. I need to do new image, and the revision would have been 2. I think my time is up, but I would love to take some questions if you guys have any questions. Go ahead.
My Helm charts are stored in a different Git repository. Does Scaffold support installing charts from somewhere else?
Yeah, you can provide relative paths or absolute paths to it.
So Helm registries?
Actually, I have not tried Helm registry. I do not know enough about that. But the Scaffold guys have a Slack channel. They're super helpful. I'm just like a newbie user of Scaffold. I'm an intermediate, maybe. There you go. Yeah, they have a roadmap in GitHub. I know they have a lot of exciting things. I don't want to ruin it because it's something exciting coming up. I don't want to be the guy who would like say it. I let them do it.
Question about the Minikube. You said that the Kubernetes in container will be in the next release.
Yes, I am hoping for mid-October to be there. But I told you guys I have a crazy travel story. Something like I'm kind of stuck. I lost my passport and everything. I don't know when I go back to the United States. So as soon as I go back to the United States, I'll work on that. Any other questions? Yeah, go. Yeah. That's not on the near term, not October, but in 2020, yes. In 2020, that's on the roadmap, but not in near term. So I cannot say in the next 6 months. The multi-node till now has not had like a great story for us to support it, but we start to learn that actually there are stories for it. The stories are still not like the main stories of testing Kubernetes, but there are, and we have it on the roadmap and as the long-term priority. Yeah. Any other questions? All right, that's it. Thank you so much.